In this video, we're going to do a few practices with weight and volume percentages. First, give this a try. 120 milliliters of 14% acetone has how many milliliters of acetone present? All right, well, if you give it a shot, we have 120 milliliters of the solution. So acetone in water is usually things like nail polish remover. It's the most common. And so you have 120 milliliters of it, and you want to know how much of it is actually acetone. What I need is a ratio of milliliters of solution to milliliters of the chemical. That's going to result in when we multiply and divide, our milliliters of solution canceling out. And we'll be left just in the milliliters of the chemical acetone. Well, that ratio comes from our percentage. It is 14%, which tells us it is 14 milliliters of the solute over 100 milliliters of the solution. The chemical that we're talking about is acetone, so it's our solute. The milliliters of solution is out of 100. So 120 times 14 divided by 100 will be 16.8 milliliters. And 2 sig figs, so this will end up rounding to about 17 milliliters. So in a 120 milliliter portion of 14% mixtures, there will be just about 17 milliliters of acetone inside that container. All right, second practice problem. I've got a 2.7 liter jug of 3.5% vinegar. So 3.5% vinegar is the normal home purchased vinegar. You can get a little more concentrated, but this is your standard off-the-shelf vinegar solutions. So if you ever had vinegar, it's actually mostly water. How much of that giant bottle is actually vinegar? So in this 2.7 liters, how many milliliters of vinegar is present? Well, if you give it a shot, we have 2.7 liters of solution, which if we're trying to solve stuff in milliliters at the end, we should probably convert to milliliters. Every 1 liter is 1,000 milliliters, so this is really 2,700 milliliters of solution. So I have 2,700 milliliters solution, and I want to get out of milliliter solution and into milliliters of vinegar. Well, it's 3.5%. So this is going to be 3.5 milliliters of vinegar over 100 milliliters of solution. I suppose this should have been volume to volume, though we did describe it that way in the initial bit. So I have 3.5 times 2,700 divided by 100. We'll find this is 94.5 milliliters, or basically 95 milliliters of pure vinegar. So if you have glacial acetic acid, which is effectively pure vinegar, you would need to pour out 95 milliliters of it, put it into a bucket, and then fill that bucket to 2,700 milliliters to make this solution. There's a second way to go about calculating this. We can do I'm in one unit, I need a ratio of those units and my final unit. But concentrations are just ratios. I know how much in one volume. If I have a bigger volume, say twice as much, I will have twice as much chemical. We can also solve these as equalities. We can say that, hey, there is an unknown amount of vinegar in 2,700 milliliters, but it has to be the same as 3.5 milliliters of vinegar that are in the 100 milliliters. Because realistically, to go up to 2,700 milliliters, well, if I had 100 milliliters of solution, and then I had a second, I'd have 200 milliliters of solution. I'd have twice as much volume, twice as much vinegar. Well, it's 27 more times. To go from 100 milliliters to 2,700 is times 27. The amount of stuff also has to be times 27. How we could mathematically do this is we can rearrange and solve just for x. So if you have an equality, you can multiply both sides by the value that's on bottom of x, so that the 2700 milliliters cancels. But if you do one thing to one side, you have to do it to both sides. So you can do any change you want to an equality. As long as you do it to both sides, it cancels out. And so I can get rid of the 2700 milliliters on the left by moving it over here onto the right. This now means I have vinegar all on its own, 3.5 times 2700 divided by 100. This will equal, x milliliters will equal 95 milliliters. It'll give us the exact same answer. Truth is, it does the exact same calculation. It's just another way to think about it. So these concentration changes can both be, I have an amount and I can use a ratio to change my unit, but they can also be equalities. 27 times the volume of the same solution, I just pour out 27 times more, brings along with it 27 times more material. And so my volume gets bigger and my milliliters of vinegar in that volume get bigger. Sodium hypochlorite, so ClO minus is hypochlorite anion. The sodium hypochlorite is bleach. And so if you buy a dilute bleach solution, you might have a 0.053% weight to volume bleach. If you're going to pour some in to help clean products, remove stains, things like that, maybe add 150 mils of it. But what we want to know is how many moles of sodium hypochlorite is this? Go ahead and pause and give this a try. All right, well, if you're back, well, weight to volume doesn't involve moles, it involves weight. So what we really have here is that there's 0.053 grams of NaClO in every 100 milliliters of the bleach solution. And I have 150 milliliters total. This will cancel out my milliliters of solution, and what I'll find is that 150 divided by 100 times 0.053, I'm going to find that there's 0.0795 grams of sodium hypochlorite in that 150 milliliters. So I had 1.5 times the ratio's volume, so I end up with 1.5 times the ratio's mass, 0.079 versus 0.053. This gives me my grams of bleach. But our goal was to find the moles of it. Once I know my grams, well, I can convert them. 0.0795 grams of a chemical. If I want to get out of grams of a chemical and into moles of that chemical, well, I'm going to need a molecular mass. For sodium hypochlorite, 1 sodium, 1 chlorine, 1 oxygen, it's going to be 74.44 grams in 1 mole. And so my grams of sodium hypochlorite will cancel out, and I will end up just in moles of sodium hypochlorite. 0.001068 mole, and reasonably we had 2 sig figs and 2 sig figs, so 0.0011 mole of NaClO, or 1.1 times 10 to the minus 3 moles of bleach.